Okay, section 1.1, let's get this started. Points, lines, planes, rays, and line segments. The learning goal for this section is I can identify and name points, lines, and planes and figures. The standard that we're covering is no precise definitions of angles, circles, perpendicular lines, parallel lines, and line segments based on the undefined notions of points, lines, distance along a line, and distance around a circle. However, in this section, we are not really going to be talking about angles, circles, perpendicular, parallel. So we're going to be focusing on line segments based on the undefined notions of points, lines, and distance along a line. And again, we're not talking about circles here. So, if we look at this, and I've already started writing, so let me erase this real quick. But if we look at this next page, we've got a long list of vocabulary words. Okay, this is a very vocabulary rich section, and it kind of serves the point of this is the building block of geometry. I know you've talked about what a point, a line, a plane, perpendicular lines, parallel lines, all of these concepts before you came here, but we're just going to kind of solidify it. And we need this information in order to build on this for geometry. So what is a point? Well, a point is a location. A point in geometry has no size or shape, but it's often represented using a dot. So we use a dot and a capital letter. Now we could pick A, you can pick B, you can pick any letter, it doesn't matter. Now, a point is a location. So if we're talking about a Cartesian plane, meaning we have an x-axis and a y-axis, then we need to give the x location and the y location. Okay, so a location means that it has two different points. If you're talking about that on a Cartesian plane. What about a line? Well, a line is described as a straight, continuous arrangement of an infinite number of points. It has an infinite length, but no width. So a line is a straight, continuous arrangement of points with infinite length, no width. And we use a straight line. I don't have a straight edge right here, or I would have used one, with arrows at each end going in opposite directions. This means that it goes on and on and on forever. That's where the infinite part comes in. And then you can use a couple of ways to notate this. Here I have 2 points on the line. See my heavy dots and my capital letters, so I have 2 points. So I can say this is line AB, or I can, if I had a letter in front of this, like M, I could say this is line M, or I can use the notation of A, B with a line with arrows above it, and that also denotes line AB. So we would read this right here as line AB. Let's look at this figure for just a second. You have this in your book, and we're just going to talk about some different parts of this. If I highlight, let's highlight this line right here. It's not highlighting, but I'm looking at this line right here. Okay, how can I label this? What are the different ways I can label this? Well, because I have a lowercase s at one of the ends here, I can simply say this is line S. I also have multiple points here. I have point A, I have a point C, and I have a point E. So I have to use at least 2 of those points and able to label this line. Okay, so I can say this is line AC. And because there are no other lines that go through both of those points, that would notate that these are the same line, line S. I could also say this was line CE, right? Because both C and E are also on this line. I could say this is line AE. That also works. So I have multiple representations of this. Now, could I go backwards? Yes. This is the same thing as saying this is line CA, or line EC, or line EA. And I can take it one step farther and just use symbols. Okay, and the symbol here would be AC with the line symbol above it, or CE with a line symbol, or AE with a line symbol. These all simply mean the exact same line, line S. Line S could be notated in any of these possibilities. Okay, but could I say that this is just line A? Okay, so line A means I have, we're going to go yellow, and we're going to look at this. This is my A, right? Now, at that particular point, line A means that there's only one line, right? There's only one possibility. But here, it's at a point A, and so I've got a line going this way through A, and I have a line going this way through point A. So line A does not mean just one line. So I can't use just one letter to denote this. This does not work. Okay, now if I had a little letter on the outside, it's a lowercase letter. They're always italicized, meaning they're slanted a little bit. Now that would denote an entire line. But you can't have just one capital letter which denotes a point, also saying that that's a line. We always use the lowercase letters. We've got N, M, P, and S in this particular diagram that indicates the different lines. Okay, so this picture's kind of gotten all covered up with colors, but we can still see what we need to. Let's talk about what the words coplanar, because these are next. Oh, no, we're not to plane yet. Collinear and non-collinear. Okay, what does that mean? Well, do you see the word line in here? Line, line. Okay, so collinear means that the points are all on the same line. Okay, non-collinear would mean not on the same line. Okay, if we look at this now, I just wrote that collinear means points are on the same line, non-collinear points are not on the same line, and I drew a quick figure here. And it's just two intersecting lines, and I know that because I've got arrows in all directions, so I'm talking about lines that are going infinitely, you know, of infinite length. And I have some points on here. So let's talk about what some of the collinear points would be. Now, if I look at this line right here, okay, if I look at this line right here, let's give it a little bit more, this line right here. How would I first name this? Well, I can name this saying I've got line DE or DB or BE. Those are all great ways of naming this. And the points that are collinear here would be points D, B, and E are collinear. I want to always just put one L in there. Okay, and if we look at this line here, Oh, what did I just do? Let me pause this for a second. Okay, so if I look at this now, what are my collinear points here? My collinear points in blue would be A, B, and C are collinear. Okay, but what points aren't collinear? What are some points that are not on the same line? Well, points that are not on the same line would be like point A, B, and D. Those are not on the same line. A is not on the same line with D and B. Again, we could pick two other points. We could say C, E, and D. These points are not collinear because they're not on the same line. Okay, let's talk about the word plane. What does plane mean? Well, a plane is described as a flat surface. A plane has an infinite length and width, but no depth, and extends infinitely in all directions. One real-world model of a plane is the surface of a still body of water. Three non-collinear points describe a unique plane, but planes are usually named using one italic letter near the corner of the plane as drawn. Okay, so a plane is a flat surface that extends in all directions infinitely, and we denote that using just this kind of shape. And if we had a letter down here, that would, like a lowercase letter. Just looking for my toolbox. A lowercase letter here, like, there it is. Like the letter M, we would say this is plane M. Okay. If we look at this next page for a second, we can see these are all different planes. In figure 1, you have plane Z, plane W, and plane P. Plane P, plane W, and plane Z. Okay, and if we look at this, we can see that all three of these planes intersect at one line. Okay, figure 2, again you have the three planes, plane P, plane W, and plane Z, and they don't all intersect each other, right? Plane P and plane W never intersect each other, but they both intersect plane Z at a line. And then if we look here at figure 3, again you have the same three planes, but where does plane P and plane Z, where do they intersect? Well, they intersect at this line here. Okay, and they also intersect with plane W. Plane Z intersects with plane W at this line here. Plane P intersects with plane W at this line back there. So we'll take a look at these in class, but I just want you to see this is how planes are shown, and you have a small lowercase letter in the corner of these planes. Okay. Okay, so if you had a plane